Very good morning, students. Welcome to IIT NEET or Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. So once again, I welcome all the class 6th students for today's session. As you all can see on the screen, and you are well aware, just a minute, right? As you all can see on the screen, and you are well aware. So my subject is physics. We are in class 6th. Our ongoing chapter, kinematics, that is a second chapter of the material. And today we are entering into the third and last session of the kinematics. So far we completed 2 sessions on kinematics where we learned about the basic concept of motion, rest, types of motions, and what are the terminology come across when a body is in motion, where we discussed about what is distance, what is displacement, what are the difference between distance and displacement. Like in last class, we introduced about the speed and velocity also. So today we'll continue where we stop in the last class. That is, we will continue with the distance and speed and velocity, followed by acceleration and retardation, right? So before going for this, already you have seen. Okay. So when you go back and when you start reading about the, so we hear speed and velocity, which are also a twin terms, twin words, which sound same, but there is a difference between them. So as you can see here, speed is nothing but distance by time, rate of distance traveled. Rate of distance traveled is called speed, right? Rate of distance traveled means distance traveled in a given time. As you all know, distance does not have any direction. Speed also not having any direction. So speed is a scalar quantity. Speed is a scalar quantity because it does not have any direction. Distance traveled by a time. Clear? So, you know, distance traveled is measured in meter and time in seconds or centimeters. Time always in seconds only. Or higher units of speed are kilometer per hour. So, speed is measured in either meter per second or centimeter per second, or largest unit is kilometer per hour, where you can see your vehicles and all will represent the meter. That is by a machine device called speedometer. Speedometer is used to measure the speed of at any instant of time. Okay. So kilometer per hour is the largest unit of the speed. Right? So kilometer per hour you can convert into meter per second also. You know, kilometer is nothing but 1000 meters, right? So hours you have to convert into seconds. So hours are 1 hour is nothing but 60 minutes. Each minute is 60 seconds. Right? Now it converted to seconds. So 1000 by 60 into 60, 3600 meter per second it becomes. So you can cancel out 2 zeros, 2 5s are, 2 18s are. So 1 kilometer per hour, very important conversion, per hour is equal to 5 by 18 meter per second. Right? Very important conversion in your competitive examination. Even in IIT also, this conversion will come. Whereas 1 meter per second is equal to reverse, 18 by 5 kilometer per hour. You can convert kilometer per hour into meter per second and meter per second into kilometer per hour by a simple calculation. Right? Whenever kilometer per hour is given, you have to multiply with the 5 by 18. So it will convert into meter per second. When meter per second is given, multiply by 18 by 5 to convert into kilometer per hour. So the largest speed of any vehicles is measured in kilometer per hour. Whereas small speeds you can measure with the meter per second or centimeter per second also. Right? So this is the clear picture about the speed. So there are speed can be either uniform or non-uniform. Right? See, everything is given here. See. So when you see the types of speeds, first one is average speed. Average speed is very important to calculate because when a body is not moving with the constant speed, it is changing the speed time to time. We have to calculate the average speed. So average speed is nothing but total distance traveled by total time. Total distance traveled by a body in a given total time is called average distance. Then another type of speed is uniform speed or constant speed. If body covers same distance in same time. If body covers same distance in same time, it is called uniform speed. It covers different distances in same time or same distances different time. That is called non-uniform speed. Uniform and non-uniform and average. And last type is instantaneous speed. You know what is instantaneous? At any time, at the instant. So the speed of the body at any instant of time is called instantaneous. I already told you. When you are traveling by a vehicle, two-wheelers or four-wheeler, you can see the speedometer, what speed you are moving at any time. Right? That is called instantaneous time. That's why it's given the meter here, speedometer, either digital or no matter. So 120 showing means you are traveling by 120 km per hour in a particular time. Right? So this is a complete picture of the speed. So when you come to velocity, the same, but it is considered as a displacement by time. The rate of displacement. What is by it? Because displacement is nothing but it is having the specific direction. A body moving either east, north, west, south, or east, west, northeast. When the direction is mentioned, that is called displacement. So velocity is a displacement by time, right? Displacement by time, which is also measured in meter per second or centimeter per second. Displacement, when the specific direction is mentioned, we'll call it as displacement, right? Same velocity also can be either uniform velocity, non-uniform velocity, or average velocity or instantaneous velocity. All the velocities you can find. Only difference is it is a vector quantity, whereas speed is a scalar quantity. Right? Clear? So before going for the next, we'll see one video on this, and later we'll move to the acceleration, the last topic of the chapter. Okay. We just see the difference between the small video.
That I got from a young physics student while I'm working on an array of really cool videos that I'm sure you guys are gonna like. So the question is, what is the difference between speed and velocity? That is an interesting and excellent question, because I too at some point thought they were the same thing. Now, as per usual, I'm gonna tell you what the difference is in words, and then I will explain it with an easy example. So basically, the difference between them is that velocity has a direction while speed does not. In physics, we call speed a scalar quantity, while velocity is a vector. Now that means that if we take this expression, 30 kilometers per hour, just like that, now this is speed, because it says distance over time. So this is by definition speed. As simple as that. But for velocity, now this expression would look something like 30 kilometers per hour in the north direction, or due north. Now let's take a look at a very simple example. If you took your bicycle and you want to go to the park, if you're riding your bicycle at 5 kilometers per hour until you reach the park, then your speed is 5 kilometers per hour. Is the distance that you have covered in the time it took you to cover it. But for velocity, like I said, it has to do with the direction. So for example, if you start from point A and you go with that speed in a circle and then you come back to point A again, the exact same point, then we say your speed here is 5 kilometers per hour, but your velocity here is 0. And the reason it is 0 is because there is no directional gain. You started in the same point and then you came back at the same point again. Even if you were to walk 4 meters this way, 2 meters this way, 4 meters this way, and then 2 meters up here, then your velocity or average velocity is 0 kilometers per hour. The difference between the two is like the difference between distance and displacement, basically. If you're not sure about that one, comment below and I will make a very quick video like this about it. Thank you so
much. Right. So the simple explanation for the distance and displacement. Only major difference is distance is a scalar quantity, whereas displacement is a vector quantity, right? That is a perfect difference. As is, and when you are mentioning the velocity, we'll mention a particular direction, whether it is moving towards east, west, north, south, or northeast, southeast, right? Whereas there is no need to mention the direction in case of speed. Now another pair of terms, acceleration and retardation, or acceleration and negative acceleration. So you all know common word acceleration because every vehicle will have accelerator. Accelerator is nothing but either increasing of speed or decreasing of speed. So when you raise the accelerator, the speed will increase. That is called acceleration. When you lower the accelerator, the speed will decrease. That is called deceleration or retardation or negative acceleration. So simple words, the rate of change of velocity is called acceleration. For example, say the rate of change of velocity means velocity changes with time. When velocity changes with time, it is called, for example, A is equal to V minus U by T. V is the final velocity, U is the initial velocity, T is the time taken. So V minus U is nothing but change of velocity. T is the time. So change of velocity in a given time. That is nothing but rate of change of velocity, which is termed as acceleration. As we know, the velocity is measured in meters per second and time is measured in second. So meter per second by second, meter by second square or centimeter by second square is the unit for acceleration. So acceleration is nothing but in general, you can see there, in general, the moving bodies do not have uniform velocity. For example, a cyclist moving through a busy street does not have uniform velocity. The velocity of the cyclist may change in magnitude or direction or in both. In such case, cyclist is said to have accelerated motion, right? When there is a change in the velocity from time to time, so the rate of change of velocity of a body is called acceleration. The rate of change of velocity of a body. So you can see the mathematically also V minus U by T. That is, so if the velocity of the body increases with respect to time, then acceleration is said to be positive acceleration. When you keep increasing the speed, from time to time, then you can say it as body is in acceleration. Right? Body is in acceleration. When the time is increased from time to time. Okay. So, whereas another one is negative acceleration, means decreasing of velocity. See, if the velocity of the body decreasing with respect to time, you started with a great speed, you slow down the vehicle because maybe road may be problem or there may be warning of particular kilometers. So then time to time, before coming to rest, the velocity from high level came down to the zero. Then we can say that velocity is called negative acceleration or retardation or deceleration. Anything. 3 words are terms. If the velocity of the body increases from time to time, it is called acceleration. If the velocity of the body decreases with time, it is called retardation or negative acceleration or deceleration also you can call it. It's given there. Right? So these are the two important terms which are also connected to same distance, speed, velocity, displacement and all. Okay. So as you move here. So units of acceleration is nothing but change in velocity by time taken. What? Change in velocity by time taken. That is v minus u by t. The mathematical formula for acceleration. So unit of acceleration is derived from the unit of length and time. The CGS system centimeter per second or centimeter second inverse minus SI unit is meter per second. It must be remember that acceleration is a vector quantity because velocity we are considering. Now changing the velocity is the difference between final velocity and initial velocity. That is final velocity minus initial. V minus U. That there is a mathematical formula for U. Right? See here. So acceleration is nothing but final velocity minus initial velocity into time. Final velocity minus initial velocity into time. Right? V minus U by T. What I told already. Where A is equal to acceleration, V is equal to final velocity, U is equal to initial velocity. Initial means starting velocity. Initial velocity, time taken for the change in velocity. To change the velocity from U to V, what is the time taken? That is taken as T. Right? So this is about the acceleration. If the velocity of the body increases, it is called acceleration. If the velocity of body decreases with time, it is called retardation. What you can call retardation or negative acceleration. Okay. So again, like velocity and speed, we can study the acceleration, the various forms. There can be acceleration can be either uniform or non-uniform. So uniform acceleration. When a body describes equal change in velocity in equal interval of time. Equal change, same level it is changing constantly. For 5 minutes, it becomes 0 to 5 km per hour. Next 5 minutes, again 5 km per hour. Like a constantly increasing changes, maybe with the time interval, it is said to be moving with uniform acceleration. See here. You can see giant wheel, right? When you go to the circus or exhibition, you can find giant wheel which moves around the circular path with a fixed point with constant acceleration, constant change in velocity. As long as it is moving, it moves constant. That's why the motion of the giant wheel is known as uniform acceleration, right? Or constant acceleration. The next second one, again, non-uniform acceleration or variable acceleration. So a body is said to be non-uniform acceleration. Its velocity increases or decreases unequal amounts in equal interval of times. Sometimes increasing, sometimes decreasing. If such things happens, that is called non-uniform or variable acceleration. What? Variable. Because acceleration is varying. There is a change in velocity. Sometimes it is increasing, sometimes it is decreasing. Neither constantly increasing nor constantly decreasing. That is called non-uniform acceleration. Then average acceleration. Average actually change in velocity divided by elapsed time. See, example given. The velocity of the marble increases from 0 to 60 in 3 seconds. Its average velocity is 20 because 0, see, 60 minus 0 by 3. 60 minus 0 by 3. It started from, sorry, by 2. It started from 0, moved to 60. So 2 to 30 is. So average, okay, seconds. Its average acceleration is 20 meter per second. 3 seconds, no, sorry. 3 means 20. Okay. Like that, you can calculate the average when the body is either uniform or non-uniform. Average acceleration. Clear? So this is the complete concepts of the kinematics chapter. So before going for further, one more video on difference between the.
Hello friends. Today we will discuss the difference between acceleration and retardation. So my dear friends, suppose a person is driving a car and car is moving with a certain speed, velocity. So what is basically acceleration? So let us suppose before the start of the car or before any movement, the initial velocity is u. Initial velocity is u, and after time t, suppose the velocity is v. So suppose the initial velocity is u, and suppose it is, you can put any value here, and suppose it is 30 meter per second
Where they are expecting
initial velocity, okay, at any time t, and within a 1 second, suppose the velocity is changed from 30 to 50 meter per second, and this happened within a second. So what is the acceleration?
A is
So
equal to
acceleration is v minus u divided by
30
t.
by 1.
That is rate of change of velocity. Rate of change of velocity. So in this case, it will be 50 minus 30. 50 minus 30
by 1
divided by 1. That is
20 meter per second square.
Meter per second square. 20 meter per second square. So this is the acceleration. So basically,
simple.
acceleration
A is equal to
the rate
50
of
minus
change
30 by
of
1.
velocity.
Because it started with your 30
that
meter
is
per
the
second.
final velocity
50. That is
minus
20
initial velocity
meter per second.
divided by the time t. So what is the retardation? Now,
if negative will come, retardation.
Initial
Positive
velocity
will
is
come,
50
acceleration.
meter per second, and suppose the driver applies the brake. Now, when he will apply the brake, the final velocity will be 20 meter per second. So velocity will be reduced, of course. And this happened in 1 second.
Started at 50,
so
again
as
slow down.
by the definition of acceleration, it is acceleration.
So what is happening here?
A
velocity is decreasing.
Equals to v minus
so you can
u
call it as
by
retardation.
t, rate of change of velocity. So in this case, the final velocity is
20 minus 50 by 1.
Initial velocity is 50, and time is suppose 1 second. So it is minus 30 meter per second square. It is minus 30 meter per second square. Now here you can see that
minus indicates
that by definition it is same. That is final minus initial. But here the final velocity is lesser than the initial velocity, and this will happen when we will apply the brake. So it is minus 30 meter per second square. So this is retardation. So this is retardation, or it is known as negative acceleration. So retardation is negative acceleration, or it is also known as deceleration. So my dear friends, this is the basic difference between.
Right. So this is about the last part of the chapter, that is retardation and acceleration and types. Right. So this is so related to that, there are some problems are given here. So a bus travels, for example, if you take the first problem, you can solve easily from easy only conversions. So what is given here? Just a minute. You see the first bit. A bus travels with the 72 km per hour in 2 seconds. So he's asking what is the distance travel? That is it travels in 2 seconds. A bus traveling, how far it traveling? That is distance you have to calculate. Right. So distance here, velocity, speed is given, time is given. Speed is equal to distance by time, right? We know. Right? Your conversion is required. Here it is in seconds, it is in kilometer per hour. Either you have to convert this into meter per second, or you have to convert this into hour. So how far means you have to calculate how much distance it travels. So what is the distance here? Distance traveled is 72 kilometers. So speed is, speed is equal to distance by time. Distance is equal to speed into time. Right. Speed into time. What is the speed here? 72 km per hour. You have to convert into meter per second. 5 by 18. 18 fours are 72. 4 5 are 20 meter per second. So distance is 20 meter per second and time is 2. 22 is a 40 meter. Simple. You can find in meters or you can find in kilometers also. Because one is in second, other is in kilometer per hour. Either we have to convert this into meter per second or 2 into hours also. Hour means, we can seconds into hour means again 3600 we have to do. So little difficult. Right? The speed is equal to distance by time. Simple way. You can calculate the problems continuously. Right? So velocity is equal to, see fourth one, velocity. Distance by time, 200 by, velocity is equal to distance, 200 is the distance and time is 2 seconds. So 100 meter per second, clearly there. Okay. So like this you can solve each and everything. If in any query, we have the solutions are provided, including the everything. You can consult your teacher. Simple one, nothing more in level 1, level 2 also. You can solve each and every one whenever you get the time during the revision time. We'll provide some time for revision. At that time, we'll explain each and every part because, right? So these are the different types of questions for the chapter kinematics. With this, we have completed the second chapter of this kinematics. Okay. So you can see match the following is there. Simple way. Match the following. If you see 1 kilometer per hour is equal to, I told already, 1 kilometer per hour is equal to 5 by 18 meter per second. So uniform speed is measuring meter per second. Speedometer to measure the instantaneous speed. I told the vehicles. And average velocity, total displacement by total time. Right? So uniform speed you can write this also, sorry, cover equal distance and equal time. Not this. Units also you can mention, but you go. Equal distance, equal time is nothing but uniform. Simple. Right? Anything easily you can do if you have will. 324 kilometers distance traveled. 324 kilometers given. Time is given thus minutes. Right? Either you have to convert this into meters or this into hours to get the, what is asking, calculate the displacement. So velocity is equal to displacement by time. So displacement is equal to velocity into time. Right? So what is the displacement you have to calculate as well as velocity also you can calculate. So velocity, distance by time. Distance is 224. Time is 20 minutes you are converted into 20 by 60 hours. Right? 320 by 20 by 60, you can do the calculation, you get the answer. Thing is, you need to conversions. Physics require the conversions also because when you are solving anything, all should be in same system. So like that, you can solve any kind of questions from this particular material. We already sent the solutions for you, entire solution, not only options, solutions also sent to you. Go through the solutions. So definitely you can get the good result. So next class, when you meet in next class, we'll discuss about the continuation of kinematics. Kinematics will discuss only about motion. Here we'll discuss about the cause of motion. Why body is moving? Because of the force that is absorbed by Sir Isaac Newton by his 3 important laws of Newton. Right? That is third lesson we will discuss in the next class. Right now we are done with the second chapter. First we completed units and measurement chapter, where we discussed about the units and different types of measurement, how to measure the length, time and all. Then when we started the kinematics, we discussed about rest, motion, what is the difference between them, and different types of motions like translatory motion, rotatory motion, oscillatory motion, periodic motion, random motion, circular motion. Then what are the terms related to motion? So when your body is in motion, every moving body passes distance, covers some distance, displacement. We have seen the difference also. And then see the distance and difference of the various shapes. Then what is time? How to measure the time? Because moving body, whether body is moving or at rest, time keep on moving. Then today we start with the speed velocity and acceleration retardation, right? So with this you are done with the entire chapter of kinematics, second chapter. So next class when we meet, we'll continue with the third chapter, Newton's laws, right? Till then, have a wonderful day, good, wonderful time. Right. So thank you all of you. Thank you very much.